A small sphere of mass m is launched straight upward from the top of a high cliff, as shown in Figure 1, with an initial speed v0 at time t equals 0. The air exerts a resistive force Fr on the sphere that varies with velocity v according to the equation Fr equals negative bv, where b is a positive constant. The sphere reaches its maximum height in the air at time th and then falls back down towards the ground, which is a long distance between the sphere's launch point at the top of the cliff. In the following questions, the positive direction is taken to be upward. Derive an equation for the velocity v of the sphere as a function of time t by solving a differential equation. Express your answer in terms of b, m, t, v0, and physical constants as appropriate. So, it's always best to start with what we know. We know that Fr, the resistive force, is equal to negative bv. We also know that Fy is equal to may. And we know that acceleration is equal to the derivative of velocity with respect to time. So now let's begin with Fy equals may. Remember, we're doing y because we're dealing with the y direction. And we know that Fy is going to be Fr minus mg. That's equal to ma. And because we don't have acceleration in the x direction, we'll just use a instead of ay. And substitute in negative bv for Fr. So negative bv minus mg equals ma. Now let's substitute in dv dt for acceleration. And remember, we can multiply both sides by dt, and we will get dt times negative bv minus mg equals mdv. So now divide both sides by negative bv minus mg. To give us something which we can integrate here. So we get the integral of dt is equal to the integral of mass, or m, over negative bv minus mg with respect to velocity. Now the integral of dt will just be t plus c, and that is equal to the integral of m over, let me just write the m outside, because since it is a constant, m over that is equal to m times the integral of 1 over negative bv minus mg. So just to kind of clear it up a bit, and then with respect to velocity as always. So now let's do some new substitution. So let u equal negative bv minus mg, and du is therefore equal to negative b dv. So t plus c is equal to negative m over b. So in case you guys are curious, what I'm doing here is to get negative b dv is equal to du, I'm multiplying by negative b over b. And so I have, negative b over negative b, because that equals 1. And so we have negative b inside and negative 1 over b outside. And now we will write negative b dv is equal to du. Oops, sorry, I forgot to write dv over there. Sorry if you guys got confused. So that becomes 1 over u du. So integral of 1 over u du is equal to the natural log of the absolute value of u. And u in this case is negative bv minus mg. And so now let's multiply both sides by negative b over m. And remember, c is still c because I don't know times something is I don't know. And then we get ln negative bv minus mg. So now we can rewrite this as e to that side is equal to the inside of the logarithm. So e to the negative bt over m plus c is equal to negative bv minus mg. So now we have e to the negative bt over m plus c plus mg is equal to negative bv. And then we will write v on that side, and it's equal to negative e to the negative bt over m. Sorry, I'll write c over there, and I'll explain to you why we can do that in a bit. we have minus mg over b. Now the reason we're able to do that is because of the identity, where say we have some number c to the a plus b that's equal to c to the a times c to the b, and e to that plus c is equal to e to the c times e to that, and e to the c we could just write as c because it is a constant which we don't know. So now we need to substitute in for, or find what c is. We know that v of 0 is equal to v0, or v naught. And so let's substitute that in. So that's equal to negative ce to the 0 minus mg over b. And so now let's just isolate c. We get b v naught plus mg is equal to negative c. So multiply both sides by negative 1 to get c is equal to negative b v naught minus mg. Now let's go up here for more room and substitute that in. So we get v is equal to negative bv naught minus mg times e to the negative bt over m minus mg, all divided by b. And for our final step, v of t is equal to negative, just times negative, is equal to positive bv naught plus mg times e to the negative bt over m minus mg over b. And that is our final answer. That is velocity as a function of time.